This conference will now be recorded.
Hello.
Hi.
Uh, Hi, Sai. Are you also like joining this session, or you'll be conducting? Hello.
No, I just joined. I'm also participating.
Okay, participating. Okay, okay, fine. You still have some more time.
Hello.
Hello.
Yeah. Hello. This is Satya.
మాధవి అండి.
చెప్పండి. ఇంకా స్టార్ట్ కాలేదా సెషన్ అండి?
నాకు తెలియదు, నేను ఇప్పుడే జాయిన్ అవుతున్నాను. మీ ట్రైనరా?
ఓకే. లేదు లేదండి. ట్రైనర్ కాదు, నేను కూడా జస్ట్ ఓకే అండి. వెయిట్ చేద్దాం.
రైట్.
బాయ్.
Hello friends, Welcome to this demo session on data science. I just want to check if my voice is clear and you're able to see the screen.
Hello. Yeah, your voice is clear and we are able to see the screen.
Perfect. Sorry, we got a little late. In sense, we just want to wait 5 minutes for everybody else to come. So that's the reason we started a little late. So let me start my screen.
No worries.
Okay.
Can you start now or can we wait for some more time?
No, we are starting.
Yeah, good.
So there are two topics which I would like to cover today. One is understanding of end-to-end data science. I'll give a brief overview of that. And second one, we would discuss about the curriculum, different topics we would be covering, and what would be the length of the course, the application areas, the projects which we would cover, all those things we would spend like a half an hour. But before that, I would like to give a brief understanding of the data science. Now, there are a couple of other workshops which we conducted previously. If you might have attended those workshops, there will be a slight overlap. Please bear with me. People who have not attended the workshops, it would be pretty new for you. But if you guys have attended some of my workshops in the past, there will be light overlap. Okay, but it definitely will be a refresher. I'll make it sure that it's a refresher. So to understand about data science, we are trying to understand the data science entire flow, like how it started from the start till the end, like understanding the different application areas where they will fit in and all that stuff. So we will try to understand that today. The initial applications of data science were dated very long years. I would say at least 20-30 years back we had these applications. The primary applications, the initial applications which I had worked on were primarily on the relational databases, right? So we had front-end applications which were storing their data. These were like, collecting information, the front-end applications, and they were storing the data into the relational databases. Request everybody to mute, please. If you're not speaking, request everyone to mute yourself. I'll check if there is an option for me to mute. Let me see. I don't see. Yeah. So what we are seeing is the front-end systems where we are trying to store data. So these front-end systems might be belonging to some of the businesses like retail, banking, insurance, or related things. So we would store the data into the RDBMSs, and these RDBMSs we used to run SQL queries on them. So these SQL queries, you guys are able to see my screen, right? So there are questions that, are you sharing something?
Yeah, we are able to see your desktop screen, right? That some icons we can see here.
Okay, so let me check then. It's not only the desktop. All right. Thanks for asking that. So there's a new screen I'm sharing. Probably that is not in the view.
Yeah,
So now
we can see the blue screen, right? That yeah,
right. Okay.
there is a data science heading is there, and some diagram, small diagram also there.
Correct. Okay. All right. So what I was talking was the front-end systems in the initial years of data analysis. The front-end systems used to send the queries or send the data, store the data into RDBMS's. Typical CRUD operations used to happen, and we used to run SQL queries on the RDBMSs to get some descriptive analytics. The initial applications of data science were purely descriptive analytics, where we are trying to describe the current state of data. So what is happening, what already happened. So questions related to that. If you're taking any car company, I would like to understand how many car sales happened. If you like to look at bank, we would like to understand what is the average monthly balance for the month of January, February, and March. So likewise, there could be a lot of queries based on which the businesses used to run. So based on that, they used to do the planning and other things. So such kind of systems used to run these SQL queries. Specifically, they are called as descriptive analytics on these RDBMS databases. So initial queries used to run on the direct tables. These are also called as operational data stores, ODS, or operational data stores, where they directly have the operational data stored. And these queries used to directly run on the RDBMSs, which used to create a bottleneck for any front-end transactions. Imagine you're running a big long running query, and at the same time there is a incoming transaction which is coming. For example, a, a shop person, cashier, or somebody who is trying to do some transactions, like some kgs of sugar sold, some kgs of rice sold. He is trying to do the transactions from a retail shop. That used to have a lag because there were queries running on the same database. They used to have a database concurrency, and database lags used to happen. So those were the initial problems where the businesses were pretty slow. They used to run the queries during the daytime, and because of this kind of a thing, they used to have these long running queries and used to have lags in the front end systems. But because of the lags, then people decided that let us not run these queries in the daytime. Let us run the queries in the nighttime. So slowly there was a shift from your daytime running analytical jobs to nighttime running analytical jobs. So in the mornings, people used to do regular business, banks used to run, retail shops used to run, insurance companies, car companies, everything used to run in the daytime. Example, I'm talking about US companies. And in the nighttime, imagine US nighttime, they used to run these jobs. Now the jobs could give us some descriptive analytics of that particular day or that particular week or maybe that month. So we were to run these jobs in the night where there is lowest volume, either on the night or on the weekends. So the jobs used to be scheduled in such a way, either fortnightly or monthly, and during the night, so that it is not hampering the morning time of your analytical morning time of your regular transactions. So that worked. So the next step after this was to run nightly jobs. So this worked for quite a while. Many people worked in this kind of a environment, the system admins and so on. I think at least 20-30 years back, we used to have these nightly jobs which are run every night. And what people used to do is, once the night job is done, then they used to create reports in the morning. So whoever the officials who come, the managers and all, who used to collect this information report, and then based on that, their day used to work. So this is running for quite a while. But what happened is, with the advancement of internet and the geographical expansion, the companies are no longer in one single country. They've expanded their boundaries. They have gone to other big countries. For example, a company in US has expanded its base to say Australia or Singapore or India or Dubai. So when you see there was no such time that it is a low running volume time. So when the US was sleeping, Australia was awake. When Australia was sleeping, probably UK was awake, and so on and so forth. As you're seeing, the global expansion happened, and there was no such time that okay, this is the lean period where I can run my nightly jobs, or a period where there is a least impact where we can run these nightly jobs. So that has decreased. So because of this, the new concepts came, and this came around 20 years back. And what they did is they created separate systems which are called as data warehousing. So they created systems like they created
Hello.
systems called as data warehousings. Yeah.
Okay, we are able to hear you.
Yeah. So they created systems like data warehousing. Now, what the data warehousing systems did is they kind of dumped your data from your ODSs, operational data stores, to a standalone separate data warehousing systems. Now, they were having multiple advantages. Now, data warehousing systems were kind of firstly decoupling this dependency on front-end tables with respect to the back-end warehousing tables. So the warehousing tables and the front-end tables look similar. For example, you could have both Oracle tables. They can have same kind of look and feel. The the schema of the tables could be same and all of that. And slowly their data warehousing systems evolved where they have different kind of business intelligence coupled with that, business objects creation, mapping, transformation, multiple other things came into picture. But initially, the prime idea was to decouple this kind of a dependency where my front-end systems, when I run my queries, they're having these problems. So we decouple that and then create separate systems where we dump the data. Dumping the data used to be a one-time task, and it doesn't need to take a lot of time, and that doesn't impact your queries because those were retransactions, not the write transactions. So a lot of these internal dumping used to happen at the lean time, but that definitely used to help these data warehousing, creating the data warehousing systems. Apart from the regular advantage, data warehousing systems were very well used for something called as old data, in sense the historical data capture. For example, ODSs used to have current data, means as of today, whatever is the data, we used to have that. But what happened yesterday? What happened 1 week back? What happened 1 month back? What happened 5 years back? If I want to get such kind of information, the historical data, it was very difficult to store in the ODSs, or they are not meant for it. They are transactional in nature, so they keep the current data. They were not meant for keeping past data. So data warehouses has the greater advantage that people created this historical processing. They used to dump their data every day, so we used to keep track of what has happened in the past. So we could do a lot of experimentations, like what is the change from till today to 1 month back or 1 year back. So that change data capturing systems, all those things came into picture, which has given data warehouses a great edge. Now this is working for many years. I think at least 10 years. 10 years back, these systems used to work very well. In fact, I know, like, since 2000 or 98 or so, we started data warehousing systems, and they are now almost 22 years young or old. We have good strong base systems which are set up by many of the customers who are working to run analytical queries on the data warehousing systems. But what changed slowly is the adoption of new data sources. Now, the data warehousing systems, one point is that they are very good for data which is structured in nature. So you need to have data in terms of tables or some file systems, files like CSV file or things like that. So such kind of systems where you have data in this kind of a structured nature, your data warehousing systems were very, very good. But what happened if I would like to capture something like a log data, right? So if I have a log data, for example, you have logs. Now logs could be your system logs, your operational logs, your clickstream data. You know, I can create like system ops CTRs. So a lot of this log information can be stored, and such kind of log information does or does not need to be structured in nature. Sometimes it's called as semi-structured data. To some extent it would be having structured, but most of the time it looks like a semi-structured data. So such kind of information, if I would like to store, then we would require a different kind of a storage. Secondly, if I would like to store things like images, so there's some images there, so we would like to store some images. In such kind of images, how do we store? Now this could be images or videos. So we have log kind of data, we have images data, we might also have systems. For example, we can have say like some sensor information, so there could be some sensor data. Just drawing something like a sensor. So such kind of information can also be stored. You can say sensor data. So I would like to have a system which is allowing to store data, if at all it is a log information, your images data, your sensor data, maybe some text data, right? It could be some textual information. Now text data could be any text, it could be a review, comment, information of a book or a document, whatever it is. So you are having a huge amount of text data which could be stored in a system which is capable of doing all your data processing. Now such kind of systems are having a great need to be designed, and that's where people started creating something called as data lakes. Now, data lakes is the terminology which says that it is capable enough of storing multiple kinds of systems apart from your regular file processing systems. Like now I have regular files to be processed, the database extracts to be processed. That is very well fitted in the data warehousing systems. But data lakes is the comprising of data warehouse plus other storage places which are capable enough of storing multiple data formats. Now, initially we had data lakes created in Hadoop. Now, this is what I'm talking about, 2012, 2015 kind of a time frame, where initially people started creating data lakes in something called as Hadoop systems, which are HDFS file systems. But slowly and gradually, in the current era, we are moving towards cloud, where the the data lake systems are created in cloud systems like AWS or Azure, and so on. Likewise, there are multiple options. Because of the space constraint, I'm just writing the three important ones. So Hadoop systems used to have these HDFS file systems which are capable enough of storing multiple data formats. So we used to pump in data from different systems, like whether it could be logs or images or videos or sensor data or text data. We are pumping the data to your centralized data lake systems where your data could be stored. So how this data is coming to the systems is something which involves a lot of important tools. For example, we could have tools like here we could have So here we could have tools like Bloom, can have Kafka, right? Here we have data load tools, image load tools, and so on. For sensor data and for text data, you could have basic data load tools. Here we could also use Flume. For loading your table data, people used to use something called a Scoop. So there are a lot of systems in sensor data. If at all we want to use cloud-based tools, we have something like Kinesis. So likewise, there are a lot of these tools which are connecting for bringing the data from various systems onto a centralized place. The centralized place is data lake, and these data lakes were created to process huge volumes of data. So this area of whatever we are concentrating, this area is the first piece of your data science or a prerequisite for data science, which it is called as data engineering. This area is called as data engineering. Data engineering, or a person who is responsible for this, for doing setting up of the systems, he could be called as data engineer, cloud engineer, Hadoop admin, or data ingestion engineer. So there are different names and job roles, but primarily this area of where we are trying to get in the data, right, from huge systems, different systems, into a centralized place, which is the first and foremost important factor, and that is called as data engineering. All right, so far so good. Following. If you have any questions, I would request to put it on the chat window so that it doesn't hamper the flow of the class. If you have any quick questions or small ones, you can put it in the chat window. I'll look at them and then respond at the right time. But if you have a very lengthy question, definitely you want to discuss, then stop me at some good point, and then we can discuss on that. All right. So that is the thought. So let me continue. Got it? I hope you are understanding. So the data engineering is the part in which you're trying to get this huge amount of data feeding into the data lakes, and the data lakes comprises of Hadoop or AWS or Azure and so on. And once that is done, once the data is there, we construct something called as data exploration, and the area is called exploratory data analysis. So exploratory data analysis, or it is also called as EDA, is a part of the first piece of your entire data science lifecycle, where we are trying to do the exploration of the data. While we are trying to do the exploration, we try to do a lot of things. For example, we do data pre-processing, we do data cleaning, we do something called as encoding, scaling, we do missing value imputation. I'm just writing few of them. There are a lot of them. Missing value, I can say imputation, that means the treatment. Right, so we have data pre-processing. Within the data pre-processing, we have a lot of things. We do data cleaning, like removal of columns, addition of columns, and we do encoding, which is one kind of a technique where we convert categorical variables into numerical, scaling where we transform from one space to another space, missing value imputation where we identify missing values and try to fill up the missing values, which is called as imputation, where we fill up the missing values with right set of data points. We could do normalization, standardization. So normalization is a process in which you smoothen it out. Standardization is also a similar technique. So a lot of these techniques are used for preparing your data before we apply to a modeling technique. Okay, so we have data pre-processing, data cleaning, encoding, scaling, missing value imputation, normalization, and standardization. Well, multiple techniques are there. This comes under the first set of pre-processing, and in fact it takes a lot of time for this particular section to create a good amount of data which could be fed to the machine learning modeling. Now, the modeling is a technique where we are trying to identify the pattern between input and output data, construct a model, and using that we would do future predictions. Now, that is a core of your data science, but it doesn't take a lot of time to construct that. The most of the time is consumed at this area, exploratory data analysis, because if you feed garbage to the model, which is coming next, if you feed the garbage to the model will also provide garbage. Okay, the predictions will also be garbage. So if you give garbage in, you get garbage
Hello.
out. Yeah.
Sir, how they perform these functions like data processing, data cleaning, which technology they use?
We would use, there are multiple languages are there where we can write this coding. We can use Python.
By adding columns, etc. They will use Oracle.
No, it's not Oracle. We could use, Python based tools or R or Java, Scala. There are different languages are there. In fact, during the
Okay.
course, we would be learning all those different things. Primarily,
Initially, what they use, sir?
Initially, you're talking about the initial years. They used to run only
Yes, sir.
SQL queries on Oracle. Yeah, they used to run SQL queries on Oracle, and primarily initial years they used to run filterings. You generally use SQL filterings for removing unwanted columns, created nested loops, or probably create views of your filtered data, and then upon the views you used to run queries. So that was the process in the initial years. But later these pipelines are created where we can do this pre-processing once, then after that you apply encoding, then after that you do missing value imputation, and then finally the cleaned data you would feed it to the model. So now these pipelines are created, data pipelines they call, and which are having these initial set of different processings. Once that is done, finally the cleaned data will be created that will be fed to the models.
Okay, sir.
All right. See, if you're not, if we are having some doubts and if you're not able to understand all these terms and things, please don't, don't worry. I would say that, these could be, we will go into deep on all these topics in great detail as and when we go into the course. But here I'm just trying to give this overview picture of how all these things are connected so that we appreciate how these are, connected and all. Okay, so next processing is the modeling, which is the heart of your data science process. Now modeling is the modeling is the one which uses algorithms. So these algorithms, there are plenty of algorithms. At least in our course we will be learning 20 odd algorithms where they are used for different set of processes. For example, you could use an algorithm which could use for finding prediction of something called as a supervised data, which is like you already have some output and we are trying to predict some output regarding to that. We would require algorithms to predict textual data, image data, some sequence of information. data related to real-time time series information. So such kind of different kinds of models are there, and those models will be trained on your input data so that they can understand the pattern of the input data, and you can use that pattern to predict on future data. For example, I want to create a model which can look at thousands of bank applications who are applying for bank loan, and can construct a generalized model by which, if I give a new data to that model, it should be able to predict whether the person should get a loan or not. Okay, imagine that is the application. So input to my model will be, you will have what is the salary of the person, what is the age of the person, what is the bank balance, what are the other liabilities, is he married, does he have kids, and other things. So you can have thousands of these variables which are determining the eligibility of loan. So imagine you have 1,000 observations of that variables of previously applied bank transactions or bank loan applications, and based on that you already have whether that person is given loan or not. And then what you're doing right now is you're feeding the data to the model, and the model will learn all the patterns and then finally construct a kind of an executable which you can feed new data. So that executable is nothing but, if you're feeding new data, it will basically look at the new data through the models and try to do the predictions. So this prediction is a process in which we are trying to predict a new data. Imagine we have not applied for the loan, and I am applying for the loan right now. So I feed in my age, my salary, my bank balance, my marital status, and if I have kids or not. So all those information I fill it kind of a form, and then when I apply that form, that basically comes back with the prediction saying that congratulations, you are approved for the loan, and then your loan amount is 10,50,000 rupees and so on, right? So this process of kind of doing predictions in an automated way by looking at the past data, patterns of the data, all that thing is called as modeling.
Is it a
Right?
supervised approach or a, unsupervised approach of doing this
This,
prediction?
yeah, I'm just saying this particular modeling, what I'm talking in general sense. There are
Okay.
different variants of modeling. For example, as you're asking, there is a supervised approach. That means that in the past, I get data records from the bank regarding the different loans which are applied and what was the action which was taken for that loans. Okay, 1,000 loans which are applied last year, and based on the 1,000 loan parameters, we also have whether we have given loan to that guy or not. So that is a supervised data. That means that we already have input and output for that, and we are taking that input and output, trying to understand why the loan was given and why the loan was not given, and kind of creating a gist of it and creating a model out of it, and use that model or understanding to predict something, a new data. So this is a supervised problem. Sometimes there will be problems which are unsupervised, where we don't know what is the output. We just want to create a group based on the pattern of the data. So we will get into those different types of models and all that stuff. We will get deeper into it, but for now, just understand that we are creating a kind of an algorithm which looks at the data and tries to create a generalized pattern or an understanding of the data. And while this understanding is being created, in one shot we might not be able to create this understanding right. So you would run this model in a loop, and we do something called as hyperparameter tuning. So hyperparameter tuning is nothing but to make this model good, you try to tune all the parameters for the model. Every model will have its own parameters. Typically, we call them hyperparameters, and we try to change the hyperparameters as if like you're changing a knob of a radio, so that you can exactly tune to the right amount of accuracy or right amount of output and so on. So you're trying to tune those parameters so that you get the right balance. And that parameter tuning will be happening in a loop, because the first time you run, you might not get the best accuracy or best representation of my data. So you try to run it multiple times, like 10 times, 20 times, 40 times. You run in a loop or iterations, And then after you run for multiple iterations, you would get to that point as if like you're tuning the knob of an old radio. You try to tune left and right, and then finally you meet that sweet spot where you're catching a radio station. So you're trying to tune the parameters in such a way that you're getting to the right set of parameters which are yielding towards a good algorithm. So that algorithm, whatever we are saying, is the one which could be having multiple variants. So as some people were saying, there will be variants like supervised algorithms. Within supervised, we have a lot of algorithms like decision trees. You have something like random forest. You have something like XGBoost.
Excuse me. Yeah, sorry for the interrupt that flow. Actually, I mean, I'm not aware of that part. You are saying that running the algorithm in multiple times, right? So, I mean, I cannot, uh, convert that point into the real-time environment. Like suppose I'm running a bank and I want to give a loan to some particular person, right? So in that case, if I want to run that particular algorithm or that particular tool, I mean, multiple times, it will be very difficult for me, right? So to gather the eligibility of that particular customer, right? So can you please, I mean, explain me related to real time how it's possible to run the 40 or 20 or 30 times running that particular algorithm? I mean, it is very difficult in that real time environment, like to approve a loan to particular person after running that 20 or 30 times, right? So I'm thinking that there is accuracy is missing this this process. Please correct me if my opinion is wrong.
Yeah. So I'll give a little light on what happens. So typically, say one bank, say State Bank of India. I'm just taking Indian Bank. State Bank of India, for last 1 year, it has a lot of loan applications. 1,000 applications were created, and senior officials from State Bank of India sat on the applications and they approved, rejected some of the loan applications. There were many reasons for approval or rejected. Maybe the age is less, maybe the salary is less, or maybe liabilities are more, or he already have previous existing car loans or some gold loans or something. So based on different conditions, now we are seeing different conditions regarding to the age, the salary, regarding the liabilities, other loan things, and so on. Based on all these things, there were different variants by which the loan application was rejected. Now, for somebody to sit and create all these set of rules, he can certainly go and sit and create a set of rules. Like say that if the age is greater than 35 years, or if the age is greater than 50 years, loan is rejected. If the salary is less than 20,000 per month, loan is rejected. If he has more than 3 other loans, like maybe a car loan or an education loan or some other loan, if he has more than 3 other loans, the loan will be rejected. Now we can create all these set of rules manually and then create a program, right? I can write a program in Python saying that if my if my age is greater than 55 or 50 years, your loan is rejected. You understand it, right? So we can create the manual set of rules, but there will be varied variations. The age is greater than 35 and the salary is less than 35,000, or he is he's married and having kids and having other liabilities. So you are seeing there is multiple variants of this, with which an SME, a person who is highly skilled, cannot create that varied set of rules by which he or she can create that program. Now, what we are interested here is we want to create a program which can look at the data and understand all the variations of the data and create a general approach by which the loan is approved or rejected. You're getting it? This point is clear, right, everybody?
Yeah, this is clear.
Right. So at that moment, at that moment, when we are saying that I want to create that program which can look at my data, create a pattern by which I can approve or reject a loan, then that doesn't happen in one step, right? In the first step, where we are trying to create a model, sometimes we would give more preference to the age. Sometimes we give more preference to the current existing loans, or maybe marital status, or maybe number of kids, right? So there won't be a balance when we give the data at the first go. So we might have to run that data through multiple iterations through the understanding of my algorithms, right? So algorithm will give a certain weightage to the age, certain weightage to the marital status, certain weightage to the prior existing loans. So there is some weightage to every parameter of my input, and that weightage has to be tuned. So when I'm saying the weightage has to be tuned, we want to give certain amount of weightage to every parameter. Finally, we approach to the best combination in which we are giving a right set of weightages for every parameter, and I create a generalized model. So to perform or to give right set of weightages to every parameter, we have to run my model in something called as an iteration or a loop, which will enable that to give that right set of weightages. That is what I'm talking. So the 20 times I'm talking, it's an example. It's saying that in the right first go, I might not be able to give right set of weightage, but if I tune that data with multiple examples or multiple loops, what happens is internally, and this is like one set process. You're not asking bank to give 20 times. They have given you the data, but I am looking at the data multiple times. I'm looking at it 5 times, 10 times, 20 times, looking at different variants, different angles. And then finally, we'll come back to some kind of a generalized understanding that, okay, this is the weightage for age. This is the weightage for prior loans. This is the weightage for current salary. This is the weightage for bank balance. Now, once you set up that weightage, you will construct a model. A model is nothing but you can think like a formula. It is a formula which is representing your data, and that formula will yield you to a decision of making whether you will approve the loan or reject the loan. And if you're approving the loan, how much loan you should approve. It could be 5,20,000, 8,51,000, or 10,50,000. So it could be anything, right? How much loan to be approved is also a predictive number, and that could also be achieved by these algorithms.
Okay. Yeah, thank you for your explanation. I got your point. Actually, I don't want to interrupt your flow, but I mean, I'm trying to gather in there some more knowledge. So, I mean, you are saying that whenever you are running the iteration or whenever you are running that particular condition of, I mean, particular condition means there are 1,000 conditions for applying the loan to that particular candidate. You can add that particular scenarios to your main program, and once that program is running, that main program will check the each and every eligibility criteria to approve the loan, right? So based on that percentage of that eligibility, we can decide that particular amount to grant that particular candidate. Yeah, I'm clear about this. Yeah, thanks for your I mean detailed explanation. And sorry, because of this confusion, I missed that supervised DF, DT, and RF in your screenshot. Can you please start from there?
We are not going too detailed into what are these, but I'm just saying that there are different variants of algorithms. Again, we will spend good amount of time understanding what is supervised, why we call supervised, what is every algorithm, and so on. But just take it with a pinch of salt right now that, okay, there are some algorithms which has this nature of supervised nature. So we will see what is supervised later, but there are some supervised algorithms. Within that, there are plenty of algorithms. We will learn at least 10 algorithms in the supervised machine learning itself. So we have like decision trees, random forest, XGBoost, support vector machines. Likewise, we are variants of algorithms which are in the space of supervised machine learning. And related, you have something called as unsupervised machine learning, which we have like clustering. Again, we have subsets like market basket analysis. You have PCA. Again, don't get bogged down with all these names and all. We're just thinking that there are different subsets of these plenty of algorithms which will help us to do certain kind of problem solving. So we have different set of problems. We are not having every time finding out the loan. We might have to identify whether the cell is cancerous or not. We would like to identify documents and then arrange them into news articles, sports articles, and entertainment articles. Like, there are different set of problems, and we are having different set of approaches in which solving the problems. So one set of criteria is supervised machine learning, other ones is unsupervised machine learning. A third different set is called as reinforcement learning. So likewise, we have different set of algorithms which basically provide as an approach. So these modeling algorithms will create this modeling models, and those models typically, many times people will stop here saying that we get the data, we do some processing, we apply some XYZ algorithm, and then you get some accuracy, say like 70% good, the model is 70% good or 95% good. Then once that is done, your entire course is done. Typically that is not correct. Basically, once the model is created, we also need to understand how this model is deployed. For example, these days we are deploying all these models into cloud systems. So I just take like an example of AWS cloud. What we generally do is we try to create models which can be deployed onto these clouds, and I can create a model like that. You can think like this is a model, or it is an extract of whatever the modeling is done. And then you create an API on top of the model. Now API is nothing but, somebody can call this function by giving some parameters, and then model will take those parameters, do the analysis, give the result, and the result can also be fed as a output. Typically, these results will be fed as a JSON input output, where you can call this from a front-end system. And for doing this deployment, so we deploy these models onto AWS cloud or an Azure cloud. I just say Azure, and you create API on top of it, and you can use that API for calling from another systems. So here you need to have an understanding of how do you do the deployment, maybe creating APIs or REST APIs using Flask. You need to have an understanding of, say, like Docker, other DevOps tools. So related things are there which you need to be understanding, like how these models, whatever I have trained, how these models are deployed onto systems, so that we can construct front-end systems. For example, you can create a front-end application which basically having multiple things. For example, I have multiple screens which is having some entries, and then I have kind of a button which you click that button, apply button, and what that button would do is apply your loan. Imagine this is a front-end system which is created in, say, Angular or React or say Java or any other web-based technology. So you're creating this front-end system. What this front-end system will do is it will interact with the cloud system where the model is deployed as an API, and then pass the parameters and get back the result and then show it on the front end. Now, what this could be an ICICI Bank website where It is showing the customer regarding, customer can enter the name, age, salary, and other details, and then press the apply button. Once you press the apply button, it will come back to the API. It will feed all the parameters: the age of the person, the salary of the person, the other dependencies, loans and bank balance, everything. It will feed all the data as an input. And the model API is basically the abstraction of the model, which will predict like what could be the whether the approval status, whether it is approved or rejected, and if it is approved, what is the loan amount. So it will feed back the data to the front end. So in the next screen, you would see like, congratulations, Sitaram, you are approved for the loan, and your loan amount is 10,20,000, like that. You will see that as a part of your front end screen. So this is how the systems would be connected. This is called as real-time inference. A real-time inference is nothing but where we are trying to create systems which are creating these APIs which can be fed through an endpoint, which will be called by another front-end systems, which could be written in a different language altogether, but they are calling our endpoints, where they are feeding our endpoints with input data, and we are providing an output based on our model. We'll do the prediction, and then we feed the output through the kind of a JSON or some kind of interaction between front end and the API. You got it? The second systems, typically we call it as a batch inference. So batch inference will also have similar kind of API and other things, right? So we also create the APIs for the batch as well. But the only change between the real-time inference and the batch inference is the batch inferences are fed with data. For example, we feed data, maybe some kind of text files, and then you create an output data. So in this example, the batch inference, what we do is we feed the data as a batch mode. For example, on Sunday morning, we run this batch program, and batch program will be fed with 1,000 new loan applications. The bank, ICICI Bank, will give a CSV file which is having 1,000 loan applications, and every application have their own ages, their own salaries, their own marital status, and other parameters. So we have all the 1,000 applied data. Instead of giving like a front end screen where people can log in and then apply for that, we are capturing all that information in a batch mode, and that batch process, we will give that file to the batch inference. So it will take one record at a time, do the prediction, and then it will compute an output file. We'll create an output file which is like for every customer. Imagine the customer is given some customer loan application ID. For every loan application ID, we would get the corresponding. Just a second. So what we do is we basically try to do the batch inference, where we give the input file. The input file will be fed to the batch inference model. It will do the application, then finally feed the data to the output. This is more like a batch mode. And third set of applications which are also important are called as visualization, data visualization applications. So we'll have applications like data visualization. I can write.
We also have online inference as well, right?
Online?
This batch inference, so there is online inference as well.
That is what real-time inference, whichever I'm calling.
Okay, the first one. Okay.
It's called online inference or real-time inference. The name can
There-
change, but the understanding is that.
Okay.
Right? So we can also do a lot of data visualization where basically we are trying to draw some graphs, and we are trying to represent that graphs in kind of some kind of an graph-based analysis. You can draw some histograms, pie charts, area charts, and bubble charts, different variations of there. And we have a lot of related tools which does these things. Popular ones are Tableau. You can Power BI, ClickView.
ClickView.
So these are some of the popular ones. Again, there are integration with a lot of data warehousing systems for creating BI reporting and other things. But we're not talking all that right now. But what I'm saying is some open source tools which are able to read the data from my data pre-processing things, and the data could be read from data lakes and use the data lakes for creating some reports. And these reports are created for showing some stories of how the data processing happens, how these models will be represented, and all that stuff. So such kind of things can be created where we can represent the data, we can show the data. Using the data, we can create a lot of decision making. Picture speaks more than 1,000 words, so that is a clear indication. When we can draw this entire data in terms of charts and graphs, you could do a lot of decision making very easily from whatever you have interpreted, right? So this entire screen is now filled, which gives a holistic understanding of different areas. So we started with understanding the data engineering part, where we saw that a lot of data is being ingested into the data lakes. The middle section is called as a data science part. So this is what is the data science part is, where most of the people, data scientists, all those people will work in this space, where we cover about exploratory data analysis, data modeling, again creating different types of model, doing hyperparameter tuning, and then creating related systems. So such kind of things will be done in this space. In the third area, where you're trying to create some inferences and all, typically the work will be done by somebody. So here the work will be done by data scientists, the middle area. The right area, it will be done by somebody called as ML engineer. So ML engineer is the guy or a girl who will be working on understanding of the modeling part. He will have an understanding of the Docker, DevOps. He or she will know like how to create these APIs. They will be responsible for scheduling these jobs. So there will be other tools like Jenkins, which will be required for integrating these all things, where we try to integrate these batches. Every day the batch starts at say 12 a.m. in the morning, does the job one, and after the report is created, we have another job which will be triggered, which will send emails to the people saying that congratulations Sitaram, you are eligible for so and so loan, this is the loan amount, please contact the bank for further process. Like that, you have to send emails to all the people. So such kind of systems will be created by this. So machine learning engineer is the one who is working here, and there could be UI UX engineers who will be responsible for creating the front end systems, because that is a different ball game altogether. How the site should look like, where the customer should click, which site will have a lot of clicks, and based on that the design has to be incorporated. And there will be UI UX engineers who will be working on maybe Angular, React, Java. They will be creating the front end systems, but they could invoke our APIs for doing that. Sometimes the systems will be fully integrated with Python itself. For example, the APIs and the front end systems, we can create systems with Flask and Django, where they can directly interact the APIs without doing doing an API call. They could directly do an interactions. So such kind of systems could also be created.
Who is data analytics guy? I mean, difference between data scientist and analytics.
There is a thin line. Data analytics, or if I say data analyst, who's like a lower level data scientist, I would say, and their job responsibilities is try to get the data from tables or Excel sheets, files, and try to apply some basic descriptive analytical knowledge, and then try to create some set of reports. And primarily those reports would be maybe on the Excel itself, where they get a bunch of Excel sheets and they will try to create reports out of it and then present them. So data analytics will require a lot of descriptive analytic part, where we're trying to describe what has already happened, or most of the questions are answered in that direction. Whereas data science is more of predictive in nature, where questions are answered like what is going to happen in the future, or what is the likelihood of something happening in the future. So most answers will be solved by the data scientist is more futuristic in nature, whereas data analyst or data analysis is trying to explain what has already happened and what is the current state.
Okay, I mean, I don't understand, but for some reason, many people are talking about these courses as data analytics course instead of data science. I don't know the reason
There
why
could be,
they're calling
yeah.
this.
So what I'm talking is this is data science. This is not data analytics. Again, there are these names are also overlapped or overused or over mixed up. So, if people will have the same confusion when they hear about courses like artificial intelligence, machine learning, deep learning, data science, data analytics, business analytics, right? If you're seeing, there are multiple names, but all of them are converging towards one singular point, that how do we do analysis of data, and varied ways of their data are there, and there is varied scopes. The scope is very limited. You can call it as data analytics or data analyst work. Scope is beyond and doing more algorithmic.
My point is about not data analytics. It's business
sorry for
analytics.
the interrupt your conversation. Hello.
Yeah.
Yeah. I mean, as per my knowledge, actually, I'm a data analytics, but I mean, data analytics is nothing but I think he's doing the analysis on the existing data, and he can he can say what is the nature of data, how can natural data is flow processing, and these things. But coming to data science is he can use the existing data and he can predict, or he can assume what is the what is the future and activities we can be done on the existing data, and how can the future of the business will be. That thing, I got this point. Please correct me if I'm wrong.
Yeah, that is correct. That is
So is it data analytics and business analytics both are same or different?
Business analytics, again, it would use more of what Excel spreadsheets and on those operations, and definitely that is more on a business perspective. It's more at a raw level. It doesn't use all these algorithmic process and so on. So some of the tools which are used there is you might need SQL knowledge, Excel knowledge, and file operations, report creating. So those are some of the key skills. Again, that also follows descriptive nature, but business analytics is more of a general term, where data analytics is more technical term of the same business analytics.
So who is more needed for any organization?
There are multiple requirements. Business analytics, there are a lot of people, and there were a lot of job requirements for business analytics, for business analysts for quite a few years, where data science or data scientists is more of a niche area right now, and because they are deep diving into the current data and then doing predictive abilities. So the job requirement for data scientists is growing in a in a linear fashion right now, and it is expected to grow. Somebody who is having an understanding of cloud computing and understanding of DevOps and the data science, that is a deadly combination, which I say, which is yet to stay for a long duration. So that kind of a skill set, if somebody is having, would definitely is here to stay. But it again depends upon what is my current experience level, what is my previous expertise, where I would like to fit in for the next 5 years or 10 years. So those are all bigger questions where everybody has to answer for themselves. But I am giving a direction for somebody as a general thought. But those
No,
questions has to be answered by
no,
individual person.
when you say cloud computing knowledge, so if the person, someone who is having knowledge on like solution architecting on cloud computing, would that
Hmm.
help in data science anyway?
Yeah, certainly, because I will bet on that everything in the coming few years, like 2-3 years, everything is going on cloud. Now already there is a movement, a lot of applications are already moving, but the data science is still as a nascent stage. This will certainly move into cloud. Uh, there are very competent players who are fighting for the cloud supremacy, AWS,
Mm.
Azure, and Google Cloud, but one of them will be at a higher state, and a lot of their services are overlapping also. So things which are done in AWS are also done in Azure in a similar way. Probably the syntaxes could change, but things are same. Somebody who is having a solution architect or so knowledge of cloud, if the interest is in the data science, definitely that will definitely be a plus, and I can bet my 100 rupees on that.
Okay, and then how much proficiency is required on coding part like Python, or uh, what level of proficiency is required to complete this to get a bigger picture of data science, the
Again,
processing?
depends upon what is your role expectancy. If somebody has a junior level role is expected to do good coding, he
Okay.
or she should have at least a basic knowledge of Python, functional knowledge in sense, how do you create applications using Python, how do you construct classes, write if then else loop. So basics of Python, if they have a knowledge, or basics of any language. I'm not saying only Python, but any language, any programming language. You might have done C++ long days back, or maybe expertise in Java or .NET or C# or anything else. So understanding of one language where we write a program, if that knowledge is there, that is good enough. We don't want expertise in any language. And if you if you attend the course, I would be teaching all the Python related things for data science, so that would be good enough
We
for.
mostly use libraries only, right, from Python. We don't uh, really
Yeah,
build any class or library as part of this course. That's what my
correct.
opinion is.
Partially yes and partially not. The reason is
Mm.
because if you are just leaving at the algorithmic perspective, you might just use the libraries and get the algorithm give some result. But if you are constructing a model which could be deployed as an API, and you have a complete set, right? You have the complete package, which would
Okay.
require you to construct. So you would need to have some software engineering there, where you construct the model, you write your test cases, you ensure that it is working properly for multiple varied input output categories. So there you would require software engineering, and for that you might require the coding. You're getting where I'm
Uh,
coming?
yes, yes, yes. In some
Yeah,
cases, we might have to start from scratch in the
correct.
coding. So then,
Correct.
one more query. We have many algorithms, right? And we also have different types of ML. That's like supervised, unsupervised, and reinforcement. So each ML method that supports too many algorithms. Are we going to cover all of them in this course?
We would, as I said, we would cover close to 20 algorithms. So this course, to just
In
give
all
you
three areas, in all three types of
all
ML?
three, combine all three areas. Yeah. So this course will be of a duration of 3 months, roughly 3 months, 2.5 to 3 months is the duration. And we would be covering right from the start base mathematics till the in-depth knowledge of deep learning and other areas. So we will discuss about any doubts you have, and then I will quickly walk through the curriculum so that everybody gets an understanding. I just want to give everybody a fair chance to ask their doubts on the topic what we are discussing. Once that is done, we will walk through the curriculum and see how it is structured.
Okay. Will there be any Kaggle competition or something like that after the course?
Yeah, definitely. During the course itself, I wish to conduct participate groups. In the past sessions also, we participated in groups. One of them was the Walmart regression competition. We predicted sales prediction, which the group has done decently well. The thought process is to participate in the competition, get the live feeling, right? So as the
Yes,
end
yes,
of the
yes.
course, we need to get the understanding of how do we create these end-to-end systems as the projects. So primarily focus is on the projects. We would be doing 20 projects during the course as a part of the course. More than 20, in fact 22, 23 projects will be done, and which is associated with the algorithms. That means that as I'm learning the algorithm, I will be doing an associated project, a real-time project, like how that is utilized in solving a certain problem. So we will understand that, okay, this is how the algorithm is, and this is how we solve it. And everybody to just ensure that we are trying to we are trying to do a practical theory, practical oriented course, a technical course. This is not a theory course, and we would not be having any presentations, Ashoka build trees kind of sessions. We will directly get into the algorithm and then do the coding, and this is coding oriented course. If somebody has different expectations, I would just wanted to remind them well in advance, because these 3 months will be a jam-packed sessions. We would be doing heavily coded sessions, so I would expect that the expectations is according to that. All right.
And one more thing,
Mhm.
just missed it.
Hello,
You can recollect other people.
Sitaram garu. Sorry.
Yes, madam. Yeah, madam, go
Sitaram
ahead.
garu. Sorry to interrupt you just for a minute. Yeah. This is Lakshmi from Career IT. Thanks for joining everyone. And important info from Career IT. This regular should be starting from Tuesday IST, that is 17th November. For USA people, it falls on Monday IST, Monday evening. Timings would be from 7 to 8 a.m. IST. So for other details, please do check your mails, and you can reach us the numbers whatever I have provided in chat. Thank you.
But madam,
Yeah, you can carry on, Sitaram.
sorry madam, yeah, this is Satya actually.
Yeah.
Why do you set up that session on the weekday, madam? You can set up tomorrow or weekend, right?
The weekdays only. Regular sessions weekdays only, from Monday to Friday IST. Generally, we have demos in the weekends. All the demos would be in the weekends, and regular sessions would be from Monday to Friday IST. Regular sessions weekdays only.
Yes, okay, madam.
So I'll talk to you, Satya Garu. And fine, thank you. Yeah. Please carry on, Sitaram.
And yeah, my another query is on statistics. So do we need to know stats very well in this data preparation or data science
Yeah, need
analysis?
to have
Exploratory data
good amount
analysis
of
part
knowledge.
is there, right?
Yeah. I would recommend to have good amount of knowledge, and it is part of our course itself. So we would
Okay,
learn
we'll start
mathematics
with
first.
start with maths, stats,
Yes.
and then
Yes.
okay.
Yeah. I'll walk you through the course curriculum. Those are very important, and many people ignore that, say that anyway we will be using libraries, we will not require statistics. That is not correct. We need to have a good understanding of mathematical concepts and statistical concepts. I will take you, or in fact I will drag you back to your school time and college time, where all these concepts about linear algebra, calculus, differentiation,
Yeah,
all
yes,
these things were
yes.
taught. It requires that brush up, because unless until we have that understanding, we would not understand how the model got optimized and why we are getting these output results. So because when we go to individual model topics, we would have a linkage between some mathematical topic and a statistical topic. So we need to connect all these three dots, then we have a holistic understanding, and that will help you a long way when you are facing any interviews. And if your interviewer is pretty lame and he asks some direct questions from internet, that you can anyway answer. But if he's a sound guy and is asking some real good connected questions, that will certainly be a plus for somebody who has these three dots connected: statistics, maths, and algorithms. And that is
Algorithms.
very important.
And is there going to be a checkpoint session for each knowledge area? Like you have covered maths and stats. Are we going to have any kind of test or something like that at the end of the each session?
The tests would so the what we would do is, after a module is completed, we would run an assignment, and that will not be a kind of a
Not a
test
checkpoint.
kind of a thing, but it is a practical assignment where you'll be given a problem and you were expected to solve that problem, and you can check in back your results, and I will get all the results of people, and I will give feedbacks according how the model was written, are there any improvements, and like that. It will be like a one-on-one feedback. You would not be getting a feedback in a group. So as and when we would give a timeline, like a 1 week, 2 week, depending upon the complexity of the assignment. So we are using a lot of algorithms, right? So at equal intervals, like every 2 weeks, there will be these assignments conducted, and so that you can practice those models, right?
What are
So
all
that is
tools we will be using as part of this course? Like, do we have list
the
of
course is
software
fully
tools?
designed on Python. The course is fully designed on Python. There are other languages which are also popular. For example,
Uh,
R, Scala, and Java
Go?
are also popular.
Are we
SAS,
not going to use Go?
which one?
Golang.
No, Go I'm not teaching. So what we are teaching is, we are teaching a specific one tool, one language, and getting proficiency in that. And
Okay.
Python is the most widely used language at current market, because of all the
Yes.
open source tools it has, and a lot of
Huge
external
library
connect
it is. I mean, yeah.
huge library base. So considering all of these things, definitely that will stay for a longer duration. And once we get a mastery in one language, getting on boarded to other language is not so difficult. I know people who have done courses with me, and they have expertise in Python, and then they quickly navigated to Java or R, and that was pretty straightforward, because only the understanding is there, only the syntactical changes would be different, but the understanding would be the same. So
Okay.
that is what I recommend. Or else what happens is, the course would run for, like, say 6 months or 1 year, and it doesn't make sense for somebody who is learning, and then the enthusiasm would go away, and there's no point teaching Python, R, XYZ, ABC, everything, and then making the course lengthier.
No. What I am asking is, Golang is something coming up, right? That's a Google's language. So,
Right, but the
and it is
adaptability is
also
not
free
so
source. And
much at
how?
this point. Yeah, definitely for TensorFlow and all, it is
Python
used,
is
but
there in the
adaptability.
market from last 30 years. So, uh, so, so
Correct, correct.
if
I
this
agree to that.
if Google is coming up with its own language, then it may also get picked. And tomorrow, initially, this data science and all, right, started with R.
Hmm,
So then people started moving to Python.
correct,
So R is very rarely used now in data science. Like,
correct.
and it should. Why I'm asking is like, is there any future for Go to be part of? data science programming as a priority language?
I can't say right away, but yes, there is the thought is there where the Go is being used, but not very specifically in the corporates right now at this moment. Go to some extent, the learning of the language is not so intuitive as Python is. The way the constructors are constructed in Go, the uses of other decorators or functional way of programming is a little difficult, and or not difficult, but is different the way it is done. So that's the reason
Sitaram,
it's
sorry to
yeah.
interrupt you guys. Actually, I'm happy to see that people have some bit of background on that data science tools and everything. But to me, I'm coming with a clean slate, so I don't have any details. So I expect, there is one direction, so that a lot of things are not need to be mixed up. So it creates some confusion, kind of thing. So I would request to avoid. Maybe people are interested, they can have an offline discussion with the trainer, so that other people will have a clean slate and goes in the right direction. Please, thanks.
Right. I appreciate that. I certainly I wanted to tell that, but I just want to close it at a note. Yeah. So questions related to these things. I think anything related to this topic we discussed in a good detail about the end-to-end. Anything related to this? If you have any questions, please do ask. I would also need to give a fair chance to everybody else.
Yep.
Please do ask your questions. Post it on the
Hello.
chat room if you don't wish to ask.
Hello.
Hey, hi. This is Shiva. Can you go through the course details, please?
Yeah, certainly we'll go to the course details, Shiva. I would just want to give a few minutes if we have any questions regarding to this particular topic, the way the data engineering, data science, or those things. Anybody else have questions? We would give
Yeah,
hello.
a quick question. No, it's again a different technology, but I just want to get clarification on it. Like, so what about Apache Spark? Like, it also has a streaming and machine learning, right?
Correct.
So if I want to use it, structure like you explained here, where it fits exactly.
It fits into the data engineering and exploration. So this is the area where Spark fits in. And somebody who doesn't know about Spark, it is a part of Hadoop ecosystem. It's an extension to the Hadoop ecosystem where, so what happened is for many years, like say 2010, 12 onwards, many people, big corporates invested heavily on big data ecosystems. Like they have moved their data warehousing systems to Hadoop, and a lot of ecosystem related tools came into picture, and where Spark was one of the language, or Spark was one of the framework which was heavily adopted, and it is the most widely used framework right now, this ecosystem. So we could use data science related thing in Spark also, but primarily it is used for a lot of data processing, data preparation, and all that stuff at this moment. And companies or corporates which is already heavily invested in the big data ecosystem, they are the ones who are continuing in the Spark space. And some of the algorithms, whatever we learn in the space, ML and machine learning related things, they could also be used from Spark perspective. So if you are in a space where people are already heavily invested in this and they are using Spark, that is the area. So it falls under big data ecosystem space.
Okay.
Did that clarify?
Okay. Yeah.
Hello. Hello. I'm Nagaraju here. My question is, we have many modeling tools are there available. How do we select appropriate model for a specific task? Do you teach that part?
Yeah. So that is an important thing. There are multiple models. I request everybody to go on mute, please, if you have done asking questions. I can still hear some babies.
Yeah,
they're also listening to data science.
Yeah, my son.
Okay. You know, if you're done asking question, you can go on mute. I will explain that. So
Okay.
there are multiple algorithms. Definitely, there are a lot of algorithms are there, and choosing a specific algorithm, again, it is more of a science than an art, and it actually requires a lot of considerations. The type of data being used, the amount of data being used, the sparseness in the data, and complexity of the data. For example, is the data more convoluted or is it open? Can we easily separate the data points? Is it linearly separable or not? So there are multiple layers to it, which will give us an understanding of how do we select a specific model. And there are models which are very lightweighted. That means that there are very simple models which can work effectively well when the data is easily separable. And there are very complicated models where we have multiple levels of nesting and so on, which is specifically used for data which is very complicated, or it is very complex, and there is a lot of overlapping in the data points. So those are some areas which we'll discuss in a very great detail, because it needs to understand that what is a sparse data, what is a convoluted data, how are we saying the data is linearly separable. So we need to understand all these variants. Now, once we understand those variants, we will appreciate, like, which algorithm to use at what point and why we will use. So we will understand all these things once we get to that point, right? But to give a simple answer, yes, there is an approach, is a approach which is involving multiple components or multiple layers, and that will help to get to that point.
Okay. So another question is there for the models, do we have a specific sample size is required?
No, no sample size. Specifically is open-ended. We could use any size of data. There is no such sample size which is required.
Okay.
All right.
Thank you.
Any other question?
Hey, one question.
Yeah.
Might be it may be the dumb question. Yeah, machine learning, is it falls under your diagram which you presented right now? Is it falls under the third section, modeling algorithm?
Yeah. The modeling is where we call machine learning, deep learning, other set of algorithms. Even we can write statistical algorithms here.
Okay.
But yes,
artificial intelligence is both are same. Machine learning and artificial intelligence both are same. Technically, we can call it like.
Yeah.
Because based on your algorithms, you are preparing some of the API, and that is some artificial which system is thinking based on your defined rules, right? Can I consider like that, or is it my understanding is wrong?
Yeah. So generally, let me roll over. Artificial intelligence is a bigger umbrella, which is having a clear set of hard-coded rule-based engines, where machine learning will be a subset of that, which is writing statistical models. And then you have a further subset, which is called as a deep learning. This is how technically we will talk about it. AI is a set of rules, logics, and then you can say like hand coded. Right now, if I know that for approving a loan, the age should be not greater than 55, salary should not be less than 25,000, and then he or she should not have any loans greater than 2. If I know these rules, okay, and then I can construct a rule engine which basically looks at the rules and then gives an answer. So earlier applications are purely logic based, rule based, and we used to call them as AI. So you can think about AI as a general rule based application system which can predict something based on preset rules, and a computer doing that work rather than a human doing. So based on certain set of rules, pass to the left, pass to the right, and do certain logical operations. So those are all part of AI. But when I can't give the rules, I want to get into more computer identifying the rules. That is called as ML. So we apply statistical technique right? So we apply some statistical techniques, models, algorithms, and so on, where I am not able to understand the rules. Now I have given some 1 million records of bank transactions. I do not know the rules. There are plenty of parameters are there, and I am not able to set the rules. So if I give that huge amount of data to a statistical model where it is understanding those rules and then coming up with the output model, which could be used for doing the prediction, that is called as ML, machine learning. Now we go further step, one more further step deeper, and if I give the data which is more complex enough, for example, I give images, I give videos, I give speech samples. So such kind of data points which are even more complicated for understanding the pattern, such kind of models would be dealt with deep learning. We will be covering all the three. We will be understanding what are the basics of AI. We will understand how we can write machine learning algorithms, how we can create models, how we can use it for doing predictions. We'll also get into deep learning, where we understand if at all my data is in the form of a video or an image or a speech, how do we create models which can understand that. Can I create a face recognition system? Can I create a system where I can talk to an Alexa and then it can understand my voice and reply back with some suitable answer? So such kind of systems will be part of deep learning. Deep learning, machine learning, artificial intelligence. Is it clear now?
Yeah, thank you.
Any other questions? All right, so let me quickly go through the curriculum. I'll spend like 10-15 minutes. We'll wind it up at 10 a.m. My time is 9:40 right now. So let me quickly go through the curriculum. So we will start this curriculum. There are close to 16 modules in this, and close to 20 projects we will cover as a part of this entire section. So we'll start with basic foundations. We will spend maybe a couple of days understanding all these individual components. So today's session is also part of the foundations of data science, where we are understanding the terminologies, end-to-end applications of data science, how is the implementation life cycle, what are different approaches of machine learning. So there are a lot of these things which needs to be understood, where we have to understand the subtle difference between data science, machine learning, AI. All these topics we will cover in the first few days. That covers the foundations of data science. Then we'll get into math for the data science, where we will cover linear algebra, matrices, eigenvalues, understanding of scalars, vectors, and tensors, understanding the concept of probability, prior, posterior, and conditional probabilities, applications of calculus, applications of differentiation, gradient, cost functions, and all those things will be dealt in the mathematics for data science. Now this covers the basics. It doesn't go deeper. I don't try to solve how a matrix multiplication is done. So that is not the thought here. We wanted to understand kind of a brush up on what is the topic and where it will be used in relation with the data science. So those all things will be covered in this space. Once that is done, we get into statistics for data science, and here we have two major areas of statistics. The descriptive statistics, which talks about the current state of data analysis. For example, we'll understand what are the different types of data, what are the measures of central tendencies in the form of descriptions like mean, median, mode. We do measures of dispersion. We cover about variance and standard deviation, how we do the use of these parameters in terms of modeling. We have different measures of shape, skewness and kurtosis, different types of tests of association, like how is correlation and regression working, what are different variables, different standard distributions, probability distribution, standard normal distribution, your cumulative distribution, different types of distribution functions would also be learned in this space. After that, we would get into inferential statistics, which covers about sampling, inference, different types of testing, specifically hypothesis testing. How do we do null and alternate hypothesis? What are the different types of errors which we occur in this testing? How do you conduct chi-square test, t-test, ANOVA test, and analysis of variance? How do we determine the t-value, p-value, and confidence intervals? So all those parameters will be learned in this inferential statistics. Once we complete the base of math and statistics, we get into the Python for data science, where we will learn all the important libraries which we'll use day in, day out in a data science journey. Some of the tools are NumPy, Pandas, Matplotlib, Seaborn, Jupyter Notebook. So we will get deeper into every topic. We will get into NumPy, understand how NumPy is created, what are the different methods of indexing and slicing, how do you create numerical operations, matrix operations in NumPy, how do you perform shape operations, aggregations, statistical operations, all those things, how do you perform with NumPy, we will understand that. Once that is done, we get into Pandas. It is a powerful tool for doing data operations. Now I can load it from tables, files, different structures. I could do different operations in terms of series and data frames. We could do selection, slotting, slicing. We could do descriptive analytics. We can work on multiple indexes. We can perform group by, merging, joining, concatenation. So you name it, every operation which an SQL table will do, right? It's almost similar to whatever SQL will do. All the things could be done by Pandas. So it's a very powerful tool we will be using in every of our exercise. Pandas and NumPy is a kind of a de facto standard for running any data science workflows. Once that is done, we will concentrate on the visualization tools. There are two powerful visualization tools which are available in data science, Matplotlib and Seaborn, where Matplotlib is a basic level visualization tool which is helping us to visualize the data. We would be able to understand how do we create line plots, scatter plots, how do we create histograms, how do you do different color selections, applying multiple plots, creating scatter matrix and pair plots. All those things will be learned in Matplotlib. And then we will understand Seaborn, which is another advanced visualization library, where we will cover different variants of the same plots. There are like Vineland plots, box plots, cat plots, fist grids, your pair plots, your bar plots, and LM charts. All those variants of doing the same kind of plotting would be learned in Seaborn. This will cover all the tools. Once you complete the tools, where we are completely aware about how we do data processing, we would get into something called as exploratory data analysis. Now this is the area, this structure is mimicking whatever we are learned in the diagram, right? So we get into the exploratory data analysis, where we cover about different data analytical life cycles, like how do we acquire data, prepare data, clean, visualize, how do you do model building, data inputting, data preparation, where we'll do transformation, scaling, standardization, normalization, encoding, data imputing. All those things will be learned in this particular section. So this is like pre your machine learning section, like where we are preparing your data, making it nicer, cleaner. All those things will be discussed here. Once we are done with that, we get into the machine learning part, where we understand what are the different variants of machine learning, different applications of machine learning, the understanding of supervised machine learning, classification and regression, the understanding of unsupervised machine learning and different sub areas of that. How do we do reinforcement learning? What is a model representation? How do we evaluate the model? How do you do hyperparameter tuning in machine learning models? So more like a general overview of all machine learning techniques will be learned here. Once we understand the general understanding, we get into deeper machine learning topics. For example, we get into supervised machine learning, classification. Here we will use another 7-8 models. We will be learning about k-nearest neighbor, decision trees, naive-bayes algorithms, stochastic gradient descent, support vector machine, random forest, XGBoost, logistic regression. So some 7-8 models will be learned in this classification technique, where we need to apply these models. We'll also understand how do you combine these models in terms of something called as ensembles. We will also learn about model tuning. Different types of model tuning techniques are there. Model tuning is used for getting the making the model even better. So you do train test splitting, k-fold cross validation, you will do variance bias trade-off, apply L1, L2 norms. All those things will be learned in this particular section. Once that is done, we would get into supervised machine learning regression. Regression is where we are trying to predict a number term. So for example, I want to predict the loan amount. It falls under a regression category. But if I want to predict whether I will get a loan or not, that is a classification. So yes and no is a classification. A loan amount like 5,20,000, 6,38,000. So that number term is falling under regression. Again, in regression, there are again multiple variants. You have linear regression, lasso and ridge regression, multilinear regression, your logistic regression, which is effectively a classification technique. We would have polynomial regression, random forest regression, support vector regression. So multiple variants of there. Again, here we will discuss some 6-7 models which we will apply regression techniques. Again, there are different metrics for identifying performance measures of the regression and improving those performance measures. We will do mean absolute error, mean square error, root mean square error techniques, where we identify how my model is performing. Once we complete the supervised machine learning set of algorithms, we get into unsupervised machine learning algorithms, where we will look at different clustering techniques like k-means clustering, hierarchical DB scan, and so on. We would also do association rule mining, like how do you perform a priori algorithm using market basket analysis, and performing dimensionality reduction using principal component analysis, and so on. So once we complete the unsupervised learning techniques, we get into natural language processing, where we'll understand what are the basics of text analytics, how do you perform stemming, lemmatization, stopword removal, pause tagging, name entity recognition, creating term document metrics, count vectorizer, using the term frequency for creating TF-IDF metrics. So all those things will be learned in natural language processing. In fact, natural language processing itself is a huge area. I could take a full course on NLP itself, but what we are covering here is the NLP connected with machine learning. Like how do we use NLP to construct text data to numbers and then perform machine learning models on that to do the prediction. That is what we are going to cover here. And then we get into advanced analytics, where we'll cover time series data, ARIMA models, recommender systems like content-based and collaborative filtering. And then we'll get into the reinforcement learning. We'll understand the basic concepts of reinforcement learning, different action, reward, penalty-based mechanism, feedback loop, deep Q-learning. All those things will be learned in the reinforcement learning. Then we get into the AI part. AI in sense, we'll cover the artificial neural networks, specifically in the deep learning space. We will have a general understanding of neural networks, how they are used, what is the perceptron learning, what is the feed forward and back propagation, how do you apply different mathematical techniques in AI, understanding of gradients, partial derivatives, application of linear algebra, eigenvectors, and then projections. Those all things will be learned here. We would also look at some of the tools which are popularly used, like TensorFlow and Keras. These are some of the tools which will be learned. And then we'll get into the deep learning concepts. This is the area where we are deep diving into specific data problems with related to images, videos, and text data. We will be creating chatbots. There are different application areas with respect to convolutional neural networks, where we use image data classifiers. We will learn about recurrent neural networks, where we create training sequence classifiers and time series data, creating chatbots, and so on will be learned here. So once we complete the deep learning, we would get into cloud computing for data science. As I told, two important concepts, cloud computing and DevOps, are very important for data science, without which, if somebody is saying data science, that is not at all correct. It is not in that way. So we need to understand some of the basic concepts of cloud computing. I have a good expertise in AWS, so I have covered a course section in which I teach AWS. What are the basic preliminaries? How do you do big data processing in AWS? How do you do machine learning in AWS? How do you perform deep learning on AWS cloud? How do you do NLP using AWS Lex? And different analytical services using AWS is what we can cover here. Similarly, the DevOps for data science is also very important. It plays a pivotal role in connecting all the systems, creating an automated mechanism in which the models will be created. So here we can say we could do DevOps for data science, different tasks for doing deployment of data science models. How do you deploy the models in production? How do you use containers, Dockers, and other things for deploying the models as services? How do you scale the ML models using Kubernetes? So these are all some of the techniques which needs to be understood for having an understanding of this entire area. So this covers 16 modules in which we cover full length, breadth, and width of data science. Apart from that, we have close to 20 set of projects. So we would understand about how do you do an XML to CSV converter using Python. We would build a photo editor from scratch using Flask and NumPy. We would do exploratory data analysis on retail shop analysis data, fruit prediction using k-nearest neighbor algorithm. You could do predict malignancy using namographic masses using decision tree algorithm, predict whether a candidate is shortlisted in H-1B visa using random forest algorithm, breast cancer prediction using support vector machine, HR analytics attrition using logistic regression, churn analytics in telecommunications using an ensemble modeling, predicting house prices using regression, social media ad prediction using regression, retail customer segmentation on spending patterns using market basket analysis and k-means clustering, market basket analysis using a priori algorithm, SMS spam detection using natural language processing, sentiment analysis on restaurant reviews of using natural language processing and supervised machine learning, image classification using deep learning, content-based recommender systems using deep learning, creating chatbots using recurrent neural networks and deep learning, stock market prediction using deep learning, and exploratory data analysis on crime data using NumPy, Pandas, and basic XGBoost model. So this covers close to 20 projects, and believe me, we are doing more than these. These are minimum ones. We would cover all new things, and I would recommend people who are our budding students, right? So they come up with their own use cases. We'll try to take their use cases and solve them in the class. So it's kind of a learning environment I would like to create where we do project-oriented learning, where we know like how these real-world applications are built and how we use this understanding of creating applications. So you see, every application has its own industry area. So we do retail, we do social media, we do real estate, we do telecommunications, HR, human resources, healthcare, insurance, banking. So likewise, there are plenty of application areas where we create these mini projects. So as and when we are learning an algorithm, we do the project so that we have an understanding of how this entire thing works out. All right, so I think I did a super fast rapid fire thing. So you got any questions in this?
Hi Sitaram, this is Ram here. Can you go over your background?
Okay. Mine, so I have around 15 years of experience in IT, and out of which since past 8 years, I'm working in the data area. I worked as a big data architect for a few years, and then currently I'm working as a data scientist for one of a multinational company. And as a part-time gig, I also give trainings, and in fact, teaching is my passion as well. So what I do is I do a lot of teaching, and for the past 6.5, 7 years, I'm doing teaching. I used to teach big data before, and now I'm teaching data science and Python. So that's a brief understanding. So if you want even more details, as and when we go through the course, we could understand. But overall, I have around 15 years of experience.
Yeah, your teaching is well reflected here.
Thank you.
Yeah, Sitaram, this is Satya. Can I ask one silly question?
Yeah, no question is silly. You can ask.
No. I can consider it is silly, but yeah, actually, I was trying to learn the data science, and I mean, in the last 8 months ago, but one of my friends told me that there are a lot of roles in the data scientist. Okay, at that time I got little confused and I got little scared about that roles. What are the roles are there and can I fit those roles and something, right? So, I mean, I am literally scared about that roles. There are plenty of roles. I mean, less than the 100 roles are there. I mean, so, I mean, I'm eagerly interested to learn that data scientist course, and I want to become a data scientist. But I don't know what are the, I mean, what is the role is, I mean, really suitable for me. So, I mean, can you, I mean, make me a particular, I mean, perfect person to activate that, I mean, act the particular role like that only. So, I know it is very difficult to explain each and every role right now, but can you teach me and can you make me, I mean, like a fearless person and handling the one particular role based on my background analysis? I will give you my background strengths and everything. What are the strengths I have so far?
Yeah.
Do you have that confidence on your teaching ability?
Yeah,
Do you have that confidence?
yeah, so certainly I have the confidence. In fact, I'm doing this for many years. So one thing I can say is I do have the confidence, but I also doesn't want to create it like a very flowery thing that, this course would do everything for you. There are multiple things. Again, when you're saying about the roles, it also depends upon your current years of experience, what your past background is, where you're coming from. So for example, a simple thing I would say, somebody who is coming from a data area, like a database kind of a guy or working in the data warehouse. So an entry through this data engineering would be very easy. So he or she could, easily penetrate through this front section, right? Who, for example, he has an Oracle developer or some database admin or some database developer, or worked on data warehousing system in Informatica, Cognos, BI related tools. So for such kind of guys, getting penetration through this front section or area where he or she is doing data engineering, getting into exploitative data analysis and modeling. So this is one area of path which they have to choose. Somebody who is really new to the area, so he doesn't know anything about data, he doesn't know anything about anything else. For such a guy, I would recommend to become an ML engineer who will be responsible for doing a little modeling, who will be responsible for setting up the cloud, DevOps, pipeline setting, creating the model, deploying them, creating all the pipelines. So all those things would require not a lot of modeling or technical knowledge, but that is a required field. So combination of DevOps, cloud, and modeling, and slowly they can penetrate becoming a data scientist. Or somebody who has a good knowledge of math and statistics, they can navigate here in the central area where they can become junior data scientist or senior data scientist, and they will be developing the models, dealing with the front-end teams, back-end teams, data teams, and all of that. So that is one role. Somebody who is coming from a front-end systems, like they already developed websites in Java, React, and have some front-end experience, HTML, CSS, and all that stuff. So such kind of people can navigate through this space from the back end, that they will be able to understand. They again can become ML engineers. They will know like how to interact with the models, how do you create APIs, how the endpoint interaction happens, how it will react with the front end systems, and then understanding of Dockerization, model build development, and then getting into modeling and then working on this. So somebody who is expertise in some visualization tools, they can navigate this area, like building some models like BI tools, or some business object related model will be there. So such kind of people can navigate through this space. And somebody who has batch based working, for example, an Unix admin, a Linux developer, or who has working on cron jobs, batch scheduling, such kind of people who can come in from this space, like working on the batch-based processing. And believe me, there are a lot of work in this batch-based processing also, like how do you schedule the jobs, how do you refer the jobs, how the modeling will be there, how the jobs will be triggered. So there is a good amount of work here also. So they have to navigate through this phase and then get into the modeling. So there is no one size fit answer. I don't want to give that flowery, gloomy, flowery, beautiful kind of idea that, you know, this you can do everything. But what I do is, as a part of the course, and again, many people come to me with this kind of a requirement that, okay, Sitaram, I know that this course is for 3 months, but you know, I would like to keep a realistic target of say like 3 to 6 months, and we would like to design a pathway, like how do I do it? And I have a background in testing. I have done manual automated testing, and now I want to get into this area. Where do I fit? And you know, how do I tune in my current role? And I am working for a service company, and I do see that there are a lot of data science team out there. How do I reach them? And you know, so there is a process in which I follow, where it is again one-on-one, and many people are interested, and they do come to me, and one-on-one interaction will be done, and I'll be talking to them and maybe tuning their role progression. So that is what I could help. And definitely there is a certain amount of effort which is required from your side, and I assume that that would be done by everybody who are wishing to have the transition, right? And one simple thing is that, because this is your time, effort, and money, and I'm very sure that you're not here to time pass. We are already spent 2 hours. You're hearing my voice, and I'm very happy that you're not here for doing some time pass. Definitely, you're here to put some effort, put some of your time and effort for something really good. So I would really urge everybody to do that brainstorming over the weekend. Enjoy Diwali, and then do some brainstorming that, you know, what is that you want? Why are you wanting to learn this course? Just because of some of your colleague is learning, or there is some real push where you want to learn something new or get into a better position, or have a foreseeable future which is full of all these opportunities. So you need to do that brainstorming, and then create a very concrete thought that, you know, I am going to spend the next 3 months for this, and I would like to churn myself, identify opportunity areas, work on my strengths and weaknesses to get into a better position. And that is very important. Or else what happens is you pay the money. Money is not money. Money is the least thing I would matter. It's about time. So you are giving your time and effort, which is very important. You could utilize the time somewhere else. So I really wanted to do that brainstorming. Maybe because of your background, data science might not be good. You might need to do maybe on AWS or DevOps or something else. Maybe you would not be willing to spend a lot of technical expertise, right? You just want to have a plug and play tool. Then maybe some tool-based thing is a good for you. So you need to do that brainstorming. It's not about the course.
Hello.
Yeah.
Hi, sir. Myself,
Yeah.
Shravani. Yeah, I completed BTech graduation in 2017. Till now, I didn't go to job. Why? Because I get married and I have a child. Nearly, I have 3 years gap. Initially, I am starting with the data science course. In these 3 months, after completing this course, can I get the job, and can I survive there?
You what is your background? Is it computer science background?
Yes, sir. Computer science.
How good are you in computer science?
Actually, my percentage is 83.
Okay, I think we have to take this offline, madam. But my sincere advice is no.
Yeah, why? Because I'm initially starting with data science. Why? Because it is an huge.
Yeah. Short answer is no. But you can certainly learn. But directly getting a job as a fresher with a 3 years gap.
Yeah.
You are in India or in other countries?
No, here only, sir.
India.
Andhra.
Okay. So I would say it will be difficult. I want you to
Yeah,
learn
sir.
something on Python or related area where you can spend some time and get an initial job, and then slowly you can navigate definitely. But that entry is important, and it would be unfair to me saying that you will get some job and then you get into the course. It's not at all fair. So answer is
Yeah.
no, but
Why?
certainly I can you can talk to me maybe through the career IT. We can discuss. Maybe something else could be very well suited for you. Definitely,
Why?
we will.
Because I have 3 years experience and I forgot everything. Why?
I
Because
know.
I get into married life and I have a
I
child. Now
yeah.
I can manage my child and I have to learn initially with this data science huge subject.
No,
Is
it's
it
not about
possible to
learning.
me?
Or you could do it. It is about getting the opportunity, right? You learn, spend 3 months, 6 months, and it's not getting opportunity. That is a tough thing. I'm not discouraging people, but I'm giving some
Okay.
realistic this thing, right?
Present situation also COVID, no? So can I get
This will
job and
pass away.
can I survive
This,
with? Yeah.
no, this will pass away. This is an intermittent thing. This is pass away. We need to think about futuristic things. So, okay, I think we could discuss this offline. Okay.
Sitaram,
Okay.
my name is Satish, and I have a question for you.
Yeah.
Can you hear me?
Yeah. See, one small announcement which I wish to make. So we are almost complete everything about the topic, and we discussed we discussed the curriculum. Anything you have related to curriculum or anything on the topic, anything you would like to ask, you could wait. But if you have anything else, I'm not intending to cover any technical details here. If you wish and you have some other work, definitely you can leave. And one announcement is that on coming Tuesday we will be starting the batch. It is on 17th. The batch will start at 7 a.m. IST, Indian Standard Time. Every day 1 hour will be the course, and it would go till January end till Sankranti or so. Okay, so 3 months course. So that is the information. You can certainly discuss, but if somebody who is waiting for something, information or something, and if you have some other work, definitely you can leave. Right?
Yeah.
If you wish to stay, I'm not saying people leave, but we might discuss something very personal or something which might not be of interest of everybody. Okay, you take the decision accordingly.
Yeah. So
All right, guys.
I have one question. Okay, I'm Sitaram. Hello, can you hear me?
Yeah, go ahead.
Yeah. My question to you is, you talked about data visualization. So can you throw some more light? Can you give us a little more? Can you give me a little more information about the modeling aspect and with related to data visualization and the scope of data science, the role of data science in this visualization thing?
Yeah, so the connecting part here is once you create some output models, say like batch inference, you created some output models, right? And this will be more in a textual data or maybe as a CSV file as a output. But if I give that full output to somebody, it doesn't make sense, right? It doesn't give a picture about what is the data saying. Is the sales increasing or sales decreasing? If they are increasing, what region they are increasing, and what region they are decreasing, and what could be the reason for the sales increasing in that particular area, right? So these are all predictive things, but to give a more meaningful representation, you would need a help of a data visualization guy who can look at that Excel outputs which your model is providing and then convert them into some representative graphs. So it's kind of a link between as a data scientist and a data visualization guy who can represent that data, output data is much more pictorial way. We can say that, okay, the sales is increasing in this particular area because so and so reason, and because of so and so increase in the requirement, or because of so and so things. So those linked things can be portrayed in the graphs pretty easily. Or connecting tools will be there like Tableau, Power BI, ClickView. These are some of the tools which are popular, but there are plenty other tools. In fact, we can draw the graphs using our Matplotlib and Seaborn and other libraries and show some pictorial representation of our data. Those pictures will speak more than your document or a CSV file. So that is the linkage.
Okay. So when you talk about modeling here, is it the modeling, the statistical modeling, or is it the data modeling aspect that you're talking about?
That is not data modeling. It's the statistical modeling which will try to create the relation between input and output data. A data modeling talks about the various structurization of my data, how my tables should look, and what are the varied formats and so on. But the modeling which I'm saying here is the statistical modeling. I should have written them, but generally modeling here in the data science parlance, we call it as statistical modeling.
Okay. Thank you.
Hello. Yeah, I have a question. Like, do we have any environment available, or we need to set up that environment in our systems? Like any storage system is required, or anything else?
Very good question. So I believe in doing everything for free. So we use an environment called as Google Colab, which is technically free, and only you require is a Gmail. And many people say that you buy good hardware, good laptop, and spend thousands of rupees and dollars on a good laptop. But certainly it is not required at this stage. We would be using Google Colab, which is free, and most of our course would run there. But I will also teach how to do on-premise or on laptop, where we would require some softwares. But that is not a mandatory thing. But whenever we do all these projects, right, whatever projects I showed, some of the projects will be done on like creating a model, deploying them. So those will be done on using Visual Studio Code and other IDEs. So that would require to be developed on local. But most of the course, I would say 85–90% of the course would run on Google Colab.
Okay. Yeah. Thank you so much. Yeah.
Any other questions? For 2 long hours, I'm seeing more than 20 people patiently listening. Definitely you got something out of this. I am assuming that you got some idea of things.
Yeah, it's really a demo. Like, yeah, it's very nice. Yeah.
Thank you. Actually, Sitaram, I think it's not a basic session. I can say you nailed down a lot of different topics, and a lot of touch base points are there. Thanks for your time and support today.
Yep. All right. So if you don't have any questions, we can close the session. If you have any questions, please do let me know. We'll discuss them, or else we'll. If you're interested, you can join our course. Spend few days and see like how it goes, and then take decision accordingly. All right. I wish a very happy Diwali to everybody here and abroad. Have a safe and happy Diwali. Spend your festive season nicely, and then come back with a renewed energy. I hope to talk to you on Tuesday. Thank you very much.
Yep. Happy Diwali.
Thank you so much. Thank you.
Thank you.
Thank you.
Sitaram?
Yep.
Yeah, can you provide your contact info? Or is it?
You have the details of Career IT team, so they will be the coordinating for the course. So people, I think they have provided the number, I guess. Or
Yes.
You might have got an email from them, so those will be the people you need to contact. Okay.
Yep. Thank you.
Thank you very much. All right, guys. Bye-bye.
Bye.